0.54. So this is energy level 1, 2, 3, 4, and this is 5. This is a ground state. What about the potential energy here? And what will be the similarly kinetic energy in each state? So when you make energy in the ground state, potential energy is 0, then what will happen to the other forms of energy is what we are trying to discuss here. Now, what was the basic derivation? That I think the way we derived this, the equation was of like this, no? K equal to mod of E equal to mod of U by 2. K should be equal to mod of E is that one. So mod of E. So this should be plus 13.6 electron volt. What about this? Minus 27. K2 should be equal to mod of E. So this will be 3.4. This will be minus of 6.8. Similarly, this will be 1.51. This will be minus of 3.02. These are the energies here. Now what we are doing, we are going to modify this. And the new atomic structure is what we are the new modified. So modified what means the potential energy should be 0. There should be the 0. So how to make this 0? By adding energy. How much of energy I should add? 27.2 electron volt. So that energy in the ground state will become 0. Then how much E1 will become? Plus 13.6 electron volt. What about the kinetic energy? Same. Let's come for this. E2, U2, K2. This will not change. When you had 27.2 electron volt, the potential will be altered everywhere. Will be altered everywhere. So how much it will become now? 20 point. Sir, what actually you're doing? You can ask very much that question. I should add energy of 27.2 electron volt for each state. Then when I add up that, then this will become 23.8 electron volt. When you add 27.2 minus 3.4, how much you get? 27.2. Then how to calculate this potential energy? What is the basic formula? E2 should be equal to U2 plus K2. We know E2 and we know K2. I'll write it here. So when you add up that energy to each state, so we will get this one. So this will be now, we know energy to 23.8 electron and kinetic energy remains same. We are not going to disturb the kinetic energy of electrons. So now calculate this one. Oh. I'll get back the screen. Let me construct the diagram. Yeah. This is E1. E2, this will be 3.4. I think it got erased. Let me put it again. This will be E3. Till E4 I'll write it. Minus 0.85 electron volt. This is n equal to 1, n equal to 2, n equal to 3, n equal to 4. And what is the basic central core idea? The kinetic energy is equal to mod of E mod of U by 2. It's what in this atomic structure. So therefore this U1 should be equal to 20 minus 6.8. U3 is equal to K3 will be 1.51 electron volt. So this will be minus of, no, I'm going to modify this atomic structure so that the potential energy in the ground state should become 0. So to make that potential energy in the ground state to be 0, so definitely what will happen, I am going to add energy of what? 27.2 electron volt to each state. So first you calculate when you add that much of energy, 27.2 electron volt, this will become plus 13.6 electron volt. Kinetic energy as it is, this will become 0. When you added 27.2 electron, to make potential energy 0, you have to add up that much of energy. The question is given, you should make the potential energy to be 0. Then when you add 27.2 to the minus 3.4 here, so how much will be left over? 23.8 electron volt. Then how much kinetic energy? Kinetic energy will be as it is. You calculate U2 now. So how to calculate U2? E2 is equal to U2 plus K2. So this will become 20.4 electron volt. Similarly, K3 will be how much? 1.51 electron volt. So you add 27 minus anybody value? So here what is the basic idea? 27.2 electron volt must be added to each state. Kinetic energy, the kinetic energy of the revolving particle will not change. So you subtract, no, 27 minus 2 minus 1.5, you'll get that one. Then again use this formula, E3 equal to U3 plus K3. In such an atom, if electron makes a transition from second excited state to ground state, find the wavelength of photon. I think you can work out the similar what we discussed earlier. How 47 will come? 27 minus 27.2.
24.18.
24.18. Subtract again with this, we'll get the U3.
Sir, U3 is 24.18. Sir. E3 is not 24.1.
Okay, then I'll make changes. Then this one, E3 value.
25.7.
Okay, there's a modified hydrogen atom. This is a hydrogen atom. So in this modified hydrogen atom, if they if the electron makes a transition from the third, or so like a third excited state to the ground state, what will be the wavelength of photon? So can be asked, so be careful. Huh? So something they can drag you to till there. That was the question of why we should add means, then what I should say. The potential energy should be made zero in the ground state. So I should add energy to 0.2. Sir, I want to make potential energy zero in the first excited state. Then you add 6.8 to each state. So in which state you want to add, you want to make potential energy zero, that much of energy should be added. This is a method. Got it? Okay, now it's a hypothetical atom.